Hello, everybody. Hello, it's lovely to be here. How is everybody doing? I can see quite a few people in the chat there, and I will be in the Discord. So if you have questions, you can pop all of those questions into the Discord. So as Justin said earlier, my name is Layla. I'm an MVP, I think 6 times MVP and 3 times GitHub star. I used to be a developer advocate, and now I am a full-time game developer working with Unity, but I still love enterprise architecture, and I worked for years in enterprise architecture at my previous role. I was at VMware, so spoke to a lot of customers with very big enterprisey architecture. So this was a talk that I developed whilst talking with a lot of customers there and my teammates as well. All of my teammates were Spring developers, and in Spring they're very big into modular monoliths, or moduliths as they call them. And I thought, you know what, this is a really good idea, because I heard so many people struggling with microservices and things like that. So we're gonna go ahead, and I'm going to talk to you all about all the different types of architecture and why you might want to consider a modular monolith. I'm just going to have a cough though, 1 second. Okay, so let's get ready. So this is Distribu-ready with the modular monolith. I want to start by just sharing this quote from Sir Richard Branson with you, because I think it's something that we often forget as software developers. That complexity is your enemy. Any fool can make something complicated. It is hard to keep things simple. And I think we really forget that as software developers. We start to make things complicated. We want to play. We want to build systems. We just want to make all of these amazing things, and we start to get more and more complex. And it's actually really difficult sometimes to keep things simple and concise. So that's what I want you to keep in mind as we go through everything I'm going to go through, and of course all the conference talks that you attend this week and in the future, and in your own software at home. So let's go and have a look at some architectures that you are probably very familiar with. We generally all start with a monolith. That's a single entity, and then a distributed system comes looming up on the horizon. And I think you can't help but liken it to standing stones there, and the way that all the individual services that we see there on the sarsen stones at the back in Stonehenge, you can start to see that they are connected and things like that. So I do quite like this visual. But just for those who are not familiar with these architectural approaches, let's just go over them again. So a monolithic architecture is a traditional approach where all your components are inside one repo, one system, one executable. They're generally tightly coupled, and it's very simple to develop and debug and deploy, okay, because you can just pop it on your machine and press play. Okay. On the other hand, we have microservices architecture. And this is an approach where you break your applications down into lots of services, lots of individual applications that are all talking to each other. So this gives us the benefit of being independently deployable. That's always the thing that people say, you can deploy quickly. You can just deploy hundreds of times a day. And this is always the thing that we hear when we hear about microservices. But they can be complex to develop and deploy. So what might lead you to making these choices? So usually it's because you want to scale and meet growing demand. All of our business applications, we want more users. That's usually an indication that we're being successful, that our businesses are growing. So really, we're faced with the two options, okay? So this is your existing system. You want to grow it, you want to scale it. So what do? You can start by scaling your current monolith, perhaps vertically, so you throw more compute at it, or horizontally, you have more instances of it, and you use that to meet the demand. Now you can go in and optimize your code and eliminate any bottlenecks. So that could be a good option for you. What I see a lot of people going for is like, let's do distributed systems, okay? So they start to break the app into individual services that can scale independently. All right, so just to see a little bit more detail on what the differences are between these. As I said, the monolith is really easy to develop. I say that really easy, comparatively, okay? Nothing's ever really easy to develop. And it always depends on context. But everything is contained in one system. So it's a matter of getting a copy of the code and then pressing play in your IDE or .NET Run, however you wish to run it, okay? And that's it. Conversely, when you have a microservice, you need to get loads and loads of independent services running. Now, they might be assemblies that you have no access to. You'll probably need supporting structures such as message buses and databases, and many of these, and caches and this and that, and you'll probably have them as containers. So now you are having to containerize things and have Docker. So it becomes very difficult to develop them on your local machine. Now, I know all of you are screaming Aspire at me, but we'll get to that, and that's a different situation. And then coming to updating and maintaining, and this is where we start to see the selling point of microservices. When you update or maintain a monolith, you have to go in tenderly, okay? Like, oh, what am I going to disrupt when I come in here? I don't know if you've ever gone into a system with like, just that fear of, if I touch this, what 10 other things are going to break? I've been on systems that are like that. You literally tweak a knob over here and this over here explodes. And that's because of everything being so tightly coupled, especially if you don't have things like tests in place. Now, with a microservice, you can implement new services independently of any other service, so you have less disruption on the rest of the system. Now, the scale and growth, your monolith, as we said, you can only scale it horizontally by duplicating instances, or vertically by putting more compute on it. So that's usually quite expensive. Whereas with microservices, each microservice can be scaled independently. So you're only scaling that small bit. Now, it's not quite as simple as that, because there's a lot of overhead with the systems that run your microservices, but and the way that computing works and memory and etc. But that's a whole different matter. And then deployment. With your monolith, it's pretty easy. You could right-click publish if you so desire. But generally, we see, because of this coupling, that they're deployed less frequently. I once worked at a company for 18 months, and even though we did so many commits and we were supposedly agile, in that whole 18 months, I never saw the code base released. So, you can get into this fear of release, because fear of breaking stuff. Now, as I mentioned earlier, with the microservice, you are told that you can release multiple times a day. I think it's ASOS, a big UK fashion retailer, with a big story with Microsoft. They were always at conferences, I can't even remember the name of the conference. It's not there anymore. It used to be in the Docklands in London, and they would always speak about how they could deploy thousands of times a day and things like that. So that was the selling point. So you'll start to hear these things, and you'll start to think, well, it seems like an obvious choice. We need to scale and meet our demand, and we need to go to microservices. You also might have pressure from above. I always It's probably really terrible of me to say, and I apologize if any of you are CTOs, Chief Technical Officers, that sometimes CTOs might want to say to other CTOs, oh, we've got microservices, with the hair flick, obviously, and your CTO might be going, oh, yeah, we're doing that too. And then they come back and they're like, hey, team, there's 5 of you on the team, we're going to do microservices. And you're like, but we have like 200 users a day. But now you're committed. There's also the idea of resume-driven development. That's something I think you should try and avoid. I have seen that. I've worked on projects where someone implemented just one API as Hateos, and just this one API. They didn't do it in a spike. They did it in our main application with hundreds of other APIs that were just normal APIs. And I went in and I had to make a change, and I'm like, what's going on here? He's like, oh, well, I just tried it out. And I was like, but now we have to maintain this one API in a whole different architecture. And that was resume-driven development, or just curiosity. Do those in your own spikes. So we do see these things contributing to the move towards microservices. But you may be like, no, Layla, I definitely need this. So it does sound straightforward, right? You can just go to microservices and everything will be peachy. But they do come at a cost, a big cost, and that is simplicity. Microservices are complex. Now remember, complexity is our enemy. Okay, so this is where we start to get the problems with it. So let's think about how you might approach your microservices and how you might get your journey to distribution kicked off. So I like to use this chart. We've got distribution up the left-hand side and modularization across the bottom there. And we have our monolith down in that bottom left-hand corner. It's neither distributed nor modularized. And we want to go to our microservices, which is highly modularized into all those little services and distributed. Okay, so that seems pretty straightforward. We just go straight there, don't we? No. Normally, we end up here in the left-hand side, the distributed monolith. Now, there is an element of you need to break a few eggs to make an omelette. So on your journey to modularity, you will sometimes end up in the distributed monolith area. But sadly, a lot of teams get to that point and then they have a little panic like, oh my goodness, this is so much worse. What do we do now? Do we backtrack? Do we forge forward? Do we just keep going? And it just gets worse and worse. So you may be asking, but what is the distributed monolith? Okay, so what are these dangers? Why is that a big red box? Why is that not a good place to be? So what exactly is it? We're going to use a very sort of contrived example to try and give you an idea of what this would be. Okay, so we have 2 services and they are coupled by this database. Okay, and that happens a lot because one of the first things I was always asked when I spoke about microservices is, do I really need a database per service? The answer to that is a resounding yes, you do. But a lot of teams don't do that. They're like, well, we'll just share that database. So what happens? You need to update the database to support the changes on one service. So when you go and do that and you need to do a migration, but you want to deploy now. Remember, we're doing 100 deployments a day on these services, so we need to get this out. But you've made a change to your data. What about the other service that is dependent on that database? You have now got to go and update that service, and you may not even own that service. That may be a completely different team that's running that. They may not have time to work on it immediately. So now you're stuck in this limbo, and maybe you had a critical update that you had to get out, but you've now coupled yourself. And so if we think of this, our services are tightly coupled, and you need to drag that other application along with you. So this is a really bad place to be. And what you get into is this complexity of all of your microservices, but none of the benefits. So your life just got really hard. Okay, so we've got all of that complexity. We have none of the benefits of those independent, discrete services that you can deploy as many times as you like. And then on top of that, we have none of the ease of monolithic development and debugging. Okay, so it's just the worst place to be. So as we start to go into our sort of decomposition of our services and things like that, we need to bear this golden rule in mind, and that is loose coupling and high cohesion. And the DDD fanatics out there will be like, yes, we know all about that. Yes. But this is a concept that's been around for a very long time. And this is what you need to keep at the forefront of your mind. So we're going to come back to this as we go, but I just want to keep reiterating that you need to remember loose coupling and high cohesion. So what is our more pleasant journey to distribution? So back here, we now have this modular monolith. So we go along, we don't have it distributed, we go and modularize our monolith. And then if we need to, it's much more simple to move towards microservices because we've already modularized everything, okay? So that leads us back to our, what do we need to scale and meet growing demand? Well, we've now got this third option, the modular monolith. And you may be like, oh my goodness, yes, that is the best of both worlds. Absolutely amazing. Yes, let's do it. Sold. But it does have a lot of the problems of the other two. Okay, so before we go in, we just need to understand that it does come with a lot of problems. All right, so what is the modular monolith? Okay, so it is an application where you have a monolithic code base, but you organize everything into separate, interchangeable in theory, whether you would in practice is another thing, modules or components. So this allows for improved maintainability and scalability within a single runtime environment. So that's the key, the single runtime environment, which is your monolith. But we've got all of these modules, which is kind of where you're going with your microservices, which leads me to the KitKat pattern. So I really like to think about monoliths, and well, modular monoliths being like a KitKat bar. Now, if we go to this picture, I need to know who out there eats their Kit Kat like this. I'm watching the chat now. Go on, own up. You've got a minute. Do you eat your Kit Kat like this? And I'll be checking the Discord to see. Now, if you do eat your Kit Kat like this, I only have one thing to say to you. You're monsters. All of you, monsters. Can you eat a Kit Kat like that? I mean, that's nuts. You're supposed to snap off a finger, nibble the chocolate, and then, you know, eat it like that. Oh my God, someone's eating a Kit Kat like that right now. I will come and hunt you down through the camera lens. I'm judging you right now. So why do I like to think of my modular monolith as a Kit Kat? Well, come on, slides. There we go. All right. It's basically like an entire Kit Kat bar. Each finger represents an individual module. Okay, it's the same as the big Kit Kat bar, but it's on its own. It's completely encapsulated in chocolate. It's still a wafer in chocolate, the same as the big bar, but now you have a single one. Now, if your friend has, I don't know, a matcha Kit Kat, that's my personal favorite. If anyone ever meets me and has one, you can buy my friendship with a matcha flavored Kit Kat. You can swap one of your boring milk chocolate fingers for one of their amazing matcha fingers, and it will just work. You've still got your nice modular chocolate bar, but you've swapped one of those modules. So a finger can be broken off and in itself is a self-contained chocolate bar, just like a module in your application. So I love having analogies to help me think about how software can be made more personable and better understood. Now, you're probably thinking all this talk of Kit Kats and stuff like that. How does that work in my application? Well, it is going to work like this. Let's say you have your plain old monolith. And what I want you to forget about is the type of architecture I'm using here. I'm going to use N tier because I think most people have the most familiarity with N tier, and it's the easiest to understand. But really, I don't care if you're N tier, BBOM, onion, clean, hexagon, carrot, whatever the latest new buzzwordy type of architecture is. Just simply don't care. Apply these principles to whatever architecture you're using. I'm sure you'll be able to figure it out, especially if you're using one of these other architectures. You'll know how to apply these principles to it. So we're going to slice it up vertically. So we've got our 3 tiers, our API, we have our logic, and then we have our data access layer. And we slice it all up into mini API, logic, and data access layers. Now, you may be thinking, this is a vertical slice architecture. Yes, there are some similarities, but vertical slice architecture can be applied to monoliths, modular monoliths, microservices, and it's much more about taking the entirety of a feature and implementing it in a folder. So you're modularizing it via feature rather than, say, domain or whatever that is. So it has a lot of similarity, but it is definitely not the same. So how do we go about decomposing our application? Remember, I said least coupling and high cohesion. This is a core design principle to keep in there. Now, if you're unfamiliar with this, that's okay. We're going to go into it. Elements within a module that have high cohesion and are tightly related to each other. Okay, so what we want to have is everything to do with, let's say, inventory. All inventory stuff is all very closely related. So we want that all to be together. It's highly cohesive. And that means that we can keep code loosely coupled from other things. If you had some of your inventory in this module and then you had a little bit of it in another module, you've now coupled those modules together, just a bit like the database, because, well, now if we want to do something with the inventory, are we going to this module or this module? Do we update them both at the same time? And it becomes very confusing. So we definitely want to keep everything that's very similar to each other in the same module. Okay, so if you have a box, you want to put all the red bricks in one box, all the blue bricks in another. You don't want any cross-contamination of different colored bricks in your boxes. So let's think about cohesion versus coupling. So cohesion is the degree in which elements in a module belong together. So all shades of red in one box, all shades of green in another box. And then the coupling is the degree of interdependence between them. So how much sort of, between the blue and the yellow, how much green have we got going into both of them? Okay, so you can kind of think of it like that. A module with high cohesion contains elements that are tightly related to each other, and two modules are tightly coupled if they are closely connected and dependent on each other. Now, not all coupling is bad. Sometimes we do need to couple things. It's just the degree in which you couple them. And it's all about knowing whether you've coupled them and where that coupling is and the reasons behind it. A module is said to have low cohesion if it contains unrelated elements. So you don't want inventory and orders in your one module because, what's the point? You don't want your Lego and your Duplo bits in the same box because they don't work together, okay? So modules with loose coupling work mostly independent of each other. All right, so that's all well and good. How do we start doing this? Well, we need to start incrementally with the largest chunks possible. Now, if DDD is your thing, go that way. How you determine what should be in a module is completely down to you and your team and your product. So you need to decide where your cohesion is. But remember, simplicity is your friend. So we want to start in the largest chunks possible. If you get too granular too early on, you may have too low cohesive modules where they really should be together. So big chunks, that's my big tip, okay? Then as you need to, as required, you can decompose those modules down further. So in this example, we have orders, and inside that we might have a module for returns, we might have a module for order creation and other order stuff. You may have like a single this may be a module with modules inside, and other modules may only know this as the order module. So you can start to play around with how it all works and how it fits together. And that might depend on how many teams you have, on how many people, and just what works. So I always think you need to be a little bit fluid with how you implement architecture. I always like to be very pragmatic and not dogmatic. Now, we have this pesky database, all right? As I mentioned earlier, the number one question I always get asked when I talk about microservices, do I really have to have a database per module? And if you are going microservice, yes, okay. So if we're going modular monolith, yes. So how might we do it? Code first, let's see, or database first. Now, when we go code first, as software developers, we find code, well, I do personally, code a lot easier to do. And you might get quick results when you slice up your code quicker and it's easier to understand. And then you're looking at your data and going, oh, I can't excise that bit of the data that I need from my database in the way that I thought. Or your DBA might be going, you're not doing that. And then you've got your code already modularized and pulled out, and now you have to undo all of that. So that could be a risk with going code first. So I would suggest talk to your DBA if you have one, or if you're concerned that your data might be difficult, do data first. Because if you can separate your data out into your module database, your code functionality should follow fairly easily, okay? But there's a big but now. If you decompose your module out, and you know that you are probably not going to go to distributed architecture anytime soon or ever, only in that type of thing, you could leave it like this, okay? You could have that shared data. It's not ideal, all right? So do we actually need to decompose the database? In most cases, I would advise you to, but I'm also conscious of the pressures on development teams and things like that. So it again comes back to being pragmatic, not dogmatic. But if you do choose not to decompose your data or any other thing, know that you have now accrued some technical debt. And technical debt is okay as long as you know that you have it. It's that secret technical debt that comes and bites you, okay? If you have knowledge of your technical debt, you know that it's there, that's okay, because you know about it and you know that it's lurking in the back behind you. So with all that in mind, you're probably going, how is this Distribu-ready? Okay, that's the title of the talk. So if we come back to our KitKat and we have a look at that last point there, a finger can be broken off and is in itself a self-contained chocolate bar, just like a module in your application, okay? And that is the key. Now, DHH came up with the Citadel pattern. That doesn't make any sense to me. I don't really agree with that naming. So the idea that really resonates with me is the satellite pattern, okay? I've thought long and hard about this, and I've spoken a lot about how you can have satellites around your monoliths. And I just think that this is the best description of what I think most applications should be moving towards. You can have a central, modular, if you wish, monolith that has a self-contained modules that can be broken off and become satellites, okay? So this doesn't need to be a modular monolith. This can be your monolith that you've got right now. You can carve off a satellite, and then that becomes its own standalone application. Okay, now if you're still working with a monolith and you haven't gone modular, you can modularize that one section and then break it off. And that is also a way that you can go towards distributed architecture incrementally as well. So it is a very, very good approach. So, excuse me, satellites can be converted to standalone apps, containerized, or even serverless functions. And this enables them to be scaled independently to meet demand, or scaled to zero even. So, you know, I think that is just such a great place to be. Imagine you have all like a notification service, and that's really peaky, or you want to send out emails. That's a really peaky kind of process. So you can extract that out, say deploy it into an Azure function, and when you need to run that email server or notification server, whatever it is, service, you can just scale that up to, you know, however many you need. And then when you're done and you're not sending any emails, you just scale it right back down to zero. So that's a really great way to go as with your application. Okay, so this leads us to an important question, and that is how. How do we ensure modules remain completely independent? I mean, this is the big thing. This is where we've added our complexity to our regular monolith. How do we make sure that these modules that we're putting in remain independent? How will our modules communicate? So now we've made them into these silos, but we do need to get some information across them. How do we do that? And how do we enforce this architecture? I mean, that sounds like quite a strong word, but we do need to enforce this architecture. If you go to the trouble of implementing it, you don't want in a year's time or 5 years' time for it just to become a jumbled mess. So I'm going to introduce you to my pet project that I've been working on for many years, is Tacky Tackers. And this is where I come and play with all the architecture stuff I learn from like the customers I worked with and other people and the examples I've seen. And this has a modular architecture. So we have a client. That can be whatever you wish. And then we have a web API. And then we have all the logic. So things to note. That client app could be standalone. It could be distributed off in a CDN. You might not even have a client app. And then we have the web API layer. This is your glue. It's going to hold your whole application together. It's also your executable. it is going to extend your modules. It's how everything is going to hold together. Now, our logic layer is where our modules will be, and we'll have them abide by strict intercommunication rules set out in a contract. I'm going to share my rules with you and the way that I like to design my systems, but that doesn't mean that this is the only way. You will decide what rules you'll have in your system and how you want to modularize that. And so this is just a rough idea of what you can do. This is my preferred way, and you can take it as rote, or you can elaborate on it. You can do something entirely different. So when we have our web API and all of our modules that sit underneath it, they are actually projects. So they are CS projects. All of these orders, orders.tests, orders.contracts, they are all individual projects in a solution. And that's because in .NET, we need to modularize using project files. And in our web API, this is our glue. That is the only one that we can allow to reference those main modules directly. So in here, you can see that in its CS proj, it will reference the menu, orders, payments, and kitchen. And that's because it is the glue. Now, as I say, these are the rules I'm laying out. So you can have your rules as long as you have rules that you abide by. That makes sense, okay? Now, each module can only reference contracts. They can't directly reference, like the kitchen.cs proj. It can only reference the contracts. So that's how our modules know how to communicate with each other via these contracts. So let's start with communication, and we'll start with the easy bit, the external communication. Now, we have that client, remember? So what happens? Well, the client will make a call to the web API. Let's just say it's a get, go and get all of the menus. And then that will come pushing through to the menu endpoints and return all of the menu items, for example. Okay, so then that goes off and runs the logic that's stored in the menu module. And likewise, if we want to go and make a post to say the orders, that might need to go to two different modules. So the web API will talk to the orders module and the payments module. You may have some other kind of glue in the middle. How you design it is entirely up to you. I can't express that enough. But you need to go down into these modules. And now you can start to see how the web API is the glue. Okay, so what do our endpoints look like in a module? Well, they can look like this. This is minimal APIs. I'm a big fan of minimal APIs. So let's say in our order module, we have this map order endpoints, and that's all of our order stuff. And you can break that down into lots of different things. And you can see that this is an extension method. It's extending web application. And that's important. We're going to use a lot of extension methods to manage all of this. And then we can pull those into, say you have lots of different mappings of endpoints. Maybe you like to organize them in all your gets or all your posts, and you have loads of different files or, of different classes for all of your endpoint mappings. You can bring those all together within a web application extension method. So here we're extending web application. And then here we can call app.mapOrder endpoints. And what I want you just to look at is in here, the map order endpoints, that's internal. And then here we're using a public accessor. And that's because this is the only thing that our web API project will be able to look at and access. It's just going to go in and call this one extension method. It can't look at the other one. That's all internal only, okay? And we also need to do the same with any dependencies. So that could be our database. It could be, that could be our services, anything that we want to add to our IOC, our inversion of control container in the web API, we need to write an extension for. Now, I have extended iService collection here. You may prefer to extend Web Application Builder, whatever you want, but you need to write the extension methods. And again, these are publicly accessible. And then when we go into our web API program, you can see that we can call our services.addOrders, and we can pass through our builder.configuration. And then we can also call our map add order endpoints, not the map one, that was internal, but our add order endpoints. And we've encapsulated all of the data that we not the data, the services and things that we require from our modules into these extension methods that we then call in our executable. So this will go along and add all of these things into the IOC container so that when you run the logic in your specific module, it has all of the services available to it that it needs. Okay, so that's a very nice, clean way of getting everything up and running. So that leads us on to the more complex side, which is inter-module communication. Now, some people go, yeah, we just do direct calls. We have public interfaces and our modules talk to each other directly. I've had quite a few people come up to me after I've given a talk on modular monoliths, and when I've spoken about the different ways that you can do this, they're always like, yeah, well, we just call them directly. That's fine. You can just call them directly, but you are going to be increasing your coupling. So if we look at this is all of our modules, and if they all need to talk to each other, you're going to get this tangled web. Now imagine if you need to take that one in the top right-hand side. It's got 5 other services coupled to it. So now we're going to have to go into those 5 other services and tell them, well, hey, this is now how you're going to communicate with this particular module. Maybe, I don't know, you want to change it, or you're going to swap it out, or you're going to take it out into a satellite, whatever you're doing. You're now having to go in and touch all those places. You know, it's kind of it's not impossible, but you are making it slightly more difficult for yourself by this coupling. So rather than direct calls, I would opt for using the mediator pattern. So that's not a mediator with no O. Like, you can use mediator from Jimmy Bogard if you wish, but that's not an architectural pattern in this sense. Okay, it does work with this, but we're not going off into that pattern now, but or that NuGet package. We're looking at the traditional implementation of a mediator. So communication between our objects is now encapsulated with the mediator object. And our objects no longer communicate with each other directly, and they go through the mediator, hence the name. So it does reduce that coupling between our modules. They're still coupled. We can't get away from that because they're coupled by virtue of having to speak to each other, but we've kind of made it less painful. So what does that look like? Well, we would have a mediator service, and then we'll have listeners. So each module will need some listeners. Inbound messages will get sent to a listener based on a key. So you can write your own keys and have that route to the listener that needs to listen to it. And then a service will use the mediator to notify all of those listeners by key. Okay, so that's not entirely clear, I understand, but I've got more to explain that. So we have our mediator, and let's say we've got these 3 listeners. They're all listening for various keys. So we have a new order listener, and I'll be listening for something that says about new orders. Maybe there's an order paid update listener that's listening for order paid update keys, and order detail request listener. So that obviously wants to listen for a request for order details. So they all get registered within our module mediator. So the code for that looks kind of like this. So we'll have a collection of listeners, and then we register all of those listeners on startup. They'll all be in our IOC, so they'll be in that iService collection extension method. You will put your listeners in there, and then we can go and get them from the service provider and register them like so. So that's how we can go through and get them. And then when you have a message come through, let's say you have a notify method on your mediator, it will come in, it will go and look inside your collection of listeners and pull out all of them that have the key or the relevant key that you want to send this message to, and then you will call their process message, okay? Once you've got it in place and you understand how a mediator works, it's very logical. I think you have to actually go and do it. When you just talk about it theoretically, it's not always clear. But once you start implementing it, it becomes clearer. And the second way is to use a message broker. And now we are really ramping up the complexity. So what is a message broker? Well, you have a producer producing a message, and that in-queues its message onto a message queue, and then a consumer will dequeue it when it's ready. Okay, so this is really decoupling temporally, physically, spatially, all these different things that you can go into when you start doing messaging. So we have our message broker. So the order will send a message to the message broker, and then the kitchen will pick it up when it's ready. And again, we have decreased coupling. It looks like that, which is very similar to the mediator, isn't it? Really, really similar to that message bus. And that's deliberate, because if the mediator is implemented mindfully with all those keys, the transition of the code to use a messaging system is trivial, okay? So we want to always design these things in a way that will allow them to be upgraded or extended in the most simple and efficient way. So we don't want to just slap everything in there. We can design it in such a way that the transition to a message broker is going to be as straightforward as anything can when you're implementing something that complex, okay? So a system like this is sometimes referred to as event-driven or message-driven. Things to note is that the web API, remember, that is the only executable. So all producers and consumers need to be registered in that web API. Another thing that I just want to draw your attention to, if you are going through here, is to understand the difference between thin and fat messages. So a thin message is more like an update, a quick event, and these all have an effect on traffic and just the loading of the system and how chatty your systems are. And then fat messages are ones that contain a whole load of data, and they'll become more clear if we come and look at this example from Taki Taco. So when we have an order placed, we make an API call to the order, and an order is created, and then we ask for payment to be accepted. So our payment module needs to tell the order module, which owns the order data, hey, payment has been taken, the order is now paid. So it's going to publish a thin message, an event, to the topic exchange based on the order ID and the key, which is order update paid, okay? And then the order, which is listening, whether it's the mediator or your message broker, is listening for that order update paid, and it goes, okay, this order ID is now paid, and it can go and update its data. Now, we also have the kitchen listening for a paid order, because we don't want to cook food unless it's paid for. But the payment only publishes the order ID and that the fact that it's paid, that's not enough information to go about cooking the meal. So now the kitchen service needs to go, hey, order service, I would like the details for this order. So it sends out an event, order ID, and I want the details. And then the order goes, oh, okay, I'm going to send you a big, fat, juicy message with all of the order details, and it sends it there. So, you start to get this complexity of the different types of messages, and that all comes into play. But we have now drastically increased the complexity of the system. We now have to consider error handling and implementation details of a message-based architecture. But our modules are now loosely coupled and easier to convert to satellites. Okay, so it's a playoff. What do you want from your system? Now, this leads me to preventing the inevitable. That there is a big old ball of mud. We don't want that, okay? And the ways that we can enforce that are through these various things: code review, compile time, automated tests, style guide, and things like that. So let's just go through these. Code review, I'll include pair programming here. Benefits, sharing knowledge, open discussion, challenging the status quo, all those amazing things that pair programming comes. But pair programming is maybe not the best use of time, or this is not the best use of your pair programming time, because now you need someone to know the architecture. You need them to tease through to make sure that you're adhering to the architecture. It's a big assumption that the reviewer is going to know the architecture, so that can be a big problem. But it's definitely worth doing, but maybe not for enforcement per se. Now, compile time, that's what we've really emphasized through here, through adopting the private by default or internal by default, trying to give the minimal access to other classes as you can get away. So, each module is in a distinct project or an assembly and uses the internal accessor. So other projects can't get into its innards. Okay, we don't want that. So remember this, we've got all of those separate projects. But what does that look like? So we're encapsulating our C# code, and so we have these internal classes, and now this is where the contracts come in. They are laying out what the information is in both of our modules. They're like, hey, I'm going to give you something that looks like this. This is my contract. And the other one's like, oh, okay, I know what that looks like. I can now do something with it. So in practice, let's just say we've got our order DTO, our data transfer object. So our order module is going to package up all of its order data into the order DTO, shove it off onto the mediator or the message bus. The kitchen module can come along, pick it up and go, well, I know what this is looking like because I have a contract. So I know what the order DTO looks like. And it can map it to a kitchen order DTO or something else, like if it's going to save it, can do it to an entity or whatever it needs to do, or some internal class, but it knows what it's receiving. Compile time, immediate feedback. It does require code to conform to architecture. It can be circumnavigated from reflection and the unsafe accessor, but I'll say that if you're using reflection or an unsafe accessor, you know what you're doing. You are purposefully going around and outside the rules of the system. So if it blows up in your face, that's on you. You know what you're doing. You're doing it on purpose. It is undocumented. Automated tests. So we've got two options here: static code analysis tools or architecture tests, or both. The static code analysis tools are cool. They're automated, self-documenting. You can get reports on them. They integrate into your IDEs and your CI/CD pipelines. They're pretty cool. And they detect all of these things, okay? They're very cool. So they're a good thing to have in place. They have their own weird syntax thing, and you can port them to different projects and use other people's and stuff like that. Architecture tests. So these are automated, self-documenting, very fast feedback. and all the benefits of tests, but for architecture. Now, they do take time and discipline to implement, just like any kind of testing, unit testing, or whatever type of testing you're putting in. You do need good code coverage. So what does an architecture test look like? Well, it might look like this. So classes that reside in assembly kitchen module should not depend on any types that do not reside in assembly order module. So that's saying, if it's not in there, we don't want to depend on it. And there's loads of that. There's two main test libraries. I actually have a YouTube video comparing the two of them. And they both use this Fluent API, so they're very readable. And they are a little bit tricky to get your head around, but once you do, they become pretty easy to do. You can probably use some AI tool to write them for you as well. And then we have a style guide. It's documented. We love documentation, and it's a good resource for everyone to look at. The C# style guide at Google is open there. You could use that. It's pretty extensive. You're probably already familiar with it, but you can modify it and go through that. Okay. So to summarize the modular monolith, use it where modularity is important, but you don't actually want to go the whole hog into a distributed system. Maybe you just can't justify it right now. You don't have a big enough team, or, it's just not cost efficient. But you don't have to go to a modular monolith. You can modularize some things. Some people ask, can you do it sort of halfway? Can you do it into folders? Yes, you can sort of do it. You have to be more strict, or sort of name spacing you could use to modularize it and encapsulate it. And then you'd have to do name spacing in your tests and things like that. It becomes more complicated, but you can make the principles of this work for you, okay? Key things to remember: be pragmatic, not dogmatic. Be aware of your technical debt and the good old high cohesion and loose coupling. And now, yes, can I use .NET Spire in a modular monolith? Why, yes, of course you can. It's pretty good for it, especially when you start getting your satellite. So yes, of course you can. If you want more information on various things I've spoken about, you can find me on YouTube on Layla Codes It. I've got some videos there covering all of these topics. You can hear me rant about the joys of modular monoliths on .NET Rocks. So that's episode 1856. And I talk all about my love of modular monoliths. And then here you can go. That should have an S on it. November North Games. So if you're interested in seeing what I'm doing with game development and the game I'm working on, you can find me there. And that's Blue Sky. I couldn't find a butterfly, so I found a ladybird instead. So you can find me on Blue Sky at Layla Codes It. And yeah, thank you very much. Let's go and see all of these questions. Okay. Oh my goodness, there's so much going through here. Let's see. I'm going to start in the YouTube. And that is like the creepiest AI generated art of me. I look like some weird demonic pixie thing. And there's some very weird AI in this tool. Okay, so let's go through and see the questions. Let me go up here. So let me come through. Let's see. Yes, definitely. What Thindle said, you shouldn't be doing microservices unless you can definitively say, yes, I need them. Let's say good. Good. Judging how you're eating your Kit Kat. Did anybody already work with a modular monolith? I'm interested to see that. Let's go down. Finding questions. Is there a way to enforce CSproj referencing rules? IDEs make it really easy to just accident. Yes, so that would come through your architecture tests that you would say they can't reference anything in that assembly. So definitely, that was Cameron. You would use architecture tests to enforce that referencing rules to make sure that. And then let's keep going. I just see, is there more in there coming down? I'm going to move over to the Discord. Where are we? Okay, so like Thindle says, what I'm talking about with the mediator makes it very easy to move over. And what do I think about orchestration instead of messaging? I mean, generally, it's whatever works in your system. I wouldn't say that one is better than the other. It's what your expertise in your team is for, where it all lies, and things like that. So I think generally go where your knowledge is. That's important, and then followed by the needs of your system. There we go. Okay, follow-up question. Is there any neat existing solution for architecture tests? You don't have to do any with reflection. I've got a whole talk, a whole video on architecture tests. So there's libraries out there that will do it for you. You don't need to use reflection. And for tests, you can use the internals visible to inside your CS proj. So you can open up in your test project, you can say internals visible to my test project, okay? So let's have a look on the Discord. Let's see if there's anything here. Okay, great. So we've got the questions start from here. Yes, definitely the biggest complexity is understanding the domain. That's what you really need to spend a lot of time doing, understanding what that is. Okay, let's see. Okay, right. I can't see any other questions. If you do have them, you can ping me later on there. Yes, it's on the video. I can drop a link in the Discord server for it. Okay, I'll drop it in the Solution2 chat. I'll drop a link to that if that helps you, Cameron, or in the chat here. I'll find that. But yeah, I think that is a wrap. You can find me in the Discord chat server. If you do have more questions, you can just ping me and ask me, and I can try and you found it. Perfect. So yeah, thank you so much for having me. I don't know if Max is around and if that's it, and I'm hopefully bang on time, 2 minutes over, but that's okay. And thank you so much, everybody. So yeah, I'm just going to smile now. Bye, Thindle.